So this is a sample calculation of that support only. See here, from the span first 332, span second 257, as alternate bars are bent up divided by 2. So this is what the AST available at the support. Now how much AST is required? It is 384. We have to subtract this 384 from this 259 from this 384. Therefore extra top bar is required is 90 mm square. Okay. Similarly for second bar it is 257 is required. Subtracting it, we get a extra top bar at the second support is nothing but the 96 mm square. Okay. Then the next check which we required is check for the depth. After calculation of the movement, usually we should give the check for the depth, and then we should move for the area of the steel or the steel calculation. So D required is equals to mu upon Ru max into B. Okay. So substituting the maximum movement, as it is a continuous slab, what we do here we substitute the maximum movement and dividing it by the Ru max into B is 1000, and Ru max value we have calculated previously. Okay. So now substituting these values, keep again one thing in mind, mu is maximum of all the three span. Here we have taken it as a 20.12 into 10 raised to 6. See here, these are the span moment. See here, these are the span moment. Okay, here maximum movement is of 20.22. That's why here we take it as a 20.22. So AST required, small d required is 86.77, and it is very greater than our AST provided, which is equals to 120 mm. Then the check for the deflection. As we know that the deflection is calculated maximum at the center, so we check the PT at the center. Okay, here the percentage of the steel is 0.256. As AST provided is greater than AST assumed, our slab is safe in the deflection. Then we go for the check for the shear. The shear occur, maximum shear force occur next to the end support, and as that of our mu, we have the form MUD and MUL. We have the formula for the shear force also, which is equals to alpha SD WUD into L, alpha SL into WUL, okay, into LE. Substituting the values and from the coefficient calculated, we have the maximum shear force as 30.16 kilonewton. Then we calculate the tau V. Tau V is equals to VU divided by BD, so which is equals to 0.23 MPa. Now AST at the PT at the support is equals to 384.83 upon 1000 upon B into D, so into 100. So from this we get PT at the support is 0.3%. So K, as our grade of concrete is M20, okay, and we interpolate for the 3. So K is equals to 0.38. So K into tau C is equals to 0.38 into 3, and our K into tau C is greater than Vu. Therefore, our slab is safe in the shear. Now what the last part of the slab is nothing but the reinforcement detailing. Here how the reinforcement detailing is done, look over here. Here the first span steel coming from the support bent up over here. This extension is of 0.3 L. Similar here the extra top steel. Okay, here the spacing is of 150 mm. This extra top steel is provided at the support. Similarly, the steel from this span will be starting from over here. It will be bending up from at a distance of 0.15 L. Again, it will be extended in this span, and it will be extended by the distance of 0.3 times the L. Similarly, this span still will be extended in the this span also. Okay, how much it would be extended? 0.3 L. Okay, so this is how the reinforcement detailing. So dear student, this was all about the design of the one-way continuous slab. I hope you have understood all the things. If you have any queries, you may comment it in the comment section, and let us have a short revision. First of all, we have written the design constant, given things. Then we have written the design constant. Then we have calculated the depth. After calculation of the depth, we have calculated the depth. We have assumed the depth cover. Then we have calculated the effective span. Then we have calculated the loads in the form of dead load and live load separately. Then we have calculated the moment coefficient for the dead load and live load, span moment, and the support moment coefficient. After calculation of the moments, we have calculated the AST at the span, then AST at the support. Okay, then we have calculated the extra top steel. Also we have calculated the distribution steel. After the calculation of the distribution steel, we have calculated the spacing. Then we have given the check for the deflection. Then we have given the check for the shear, and finally the reinforcement detailing. So this was whole about the design of one-way continuous slab. Thank you for watching the video. Subscribe the channel and like it. In next lecture, we will be solving the numerical on the design of two-way slab. Thank you.